Okay, let's go over the CAM setup in Fusion 360 for the brass grinding iron. Nothing really complicated, just an extruded text on a piece of stock which I found in the shop, so I'm going to use what I have. Let's just go quickly over the setup. There's basically two parts. One setup is set 1 millimeter above the part, so in order to do the facing operation so that everything is nice and flat, and it's done with a 6 millimeter single flute end mill. All operations are set to 21,000 RPM. For facing operation, I set it to 1000 millimeters per minute at a 0.5 millimeter step down and 4 millimeter step over. And yeah, it worked okay. The second setup is set exactly to the height of the model. So what we get after surfacing, there's a 2D adaptive toolpath with a 1/8 inch single flute end mill. RPM unchanged, 850 millimeters per minute, 0.9 millimeter step down, and 1.5 millimeter upper load. It's just to rough out most of the material, and this is followed by 2D adaptive with a 2 millimeter end mill, and using rest machining to save a lot of time. So RPM again unchanged, feed rate 600 millimeters per minute. So a 0.5 millimeter depth of cut per pass, 0.9 millimeters optimal load. Pretty conservative, but no, it's a pretty tiny tool, so better be careful. And we have a small pocket, again with a 2 millimeter tool, 600 millimeters a minute, just 0.4 millimeter step down, and a tiny 0.5 millimeter step over, just to be sure not to break the bit. No finishing toolpaths. This here, I disable it, no need for that. We don't need shiny sidewalls. Oh, skip this. It's just a contour toolpath to clean up any residual material left after the rest machining operation, and then some chamfers. One would perhaps suffice, but I use different settings for the other so that the toolpath gets deeper inside with tiny letters. See here. so it machines a bit more material out of the tiny details. Hopefully that should be enough, and can skip or avoid using some sub-millimeter tools, which I don't like to use too much. They might work, but they need to be slow and add another tool change, so better to skip it, and if it works okay, it will save some machining time. Oh, just forgot to show you the setup for the rest of the toolpaths. So the finishing, it's not finishing, but let's call it that, toolpath which goes around the letters is set up at 500 millimeters a minute, and I think there's no material left, or should not be any left, so it's basically almost zero step over, and 1 millimeter depth of cut per pass, and to the contours, same 500 millimeters a minute. It's pretty tiny, so I think it's better to go slow. I selected 2 passes for each chamfer. Probably not necessary, but again, just being overly cautious with the tiny lettering, so not to get it damaged. And second one is basically the same. There you have it, and this is all there is to it for the cam setup. I might add another chamfer to the outside edge for the next piece. I mean, it's not bad, the touch, but maybe feel nicer with a chamfer, and the tool is already in the spindle, so why not do it? Actually, we can do it right now. So let's just duplicate the toolpath, edit, and just select tab edge. There's lots of more space here, so we can go, let's say, 0.5 millimeter chamfer width and 1 millimeter tip offset, as it's not really good to do the chamfer with the tip of the tool, so some offset is good, of course, if there's space for the tip to go into. Anyways, that should be all for the setup. Let's save it, and I'll show you the actual milling or machining videos next with some commentary. I did it before recording this part, so I already know it turned out okay. I might improve some things, but generally it's usable. It's quite fast. Can be done in a couple of minutes with a couple of tools. So yeah, I'm quite happy with it. Testing the new G-code sender called ioSender from Terry.io. Well, it's new, at least for me. I've been using BCNC so far, but this looks pretty good. Now I'm trying to find the center of a hexagonal stock, and using the probing wizard in the ioSender to find the center of the stock, the outside. It should be set up on the machine. Let's try to turn it on and see if it won't crash. The probing rod is approximately in the center of the stock, so I hope it will work just fine. So let's go. Alright, perfect. Let's now probe the Z height. Another probing wizard tab. Everything should be set up. So let's try it. Okay. The offset is set, hopefully 2 millimeters. Let's go to part Z0. Looks okay. So, and now let's try to continue. First will be a facing operation for the top side of the stock material, using some conservative settings for feeds and speeds, as I'm not familiar with brass, so let's be careful with it for the first time and see how it goes. This is a 6 millimeter single flute carbide end mill with depth of cut at 0.5 millimeter, 4 millimeter step over, and I think about 1,000 millimeters per minute. Feed rate at 21,000 RPMs. So everything's set up, I hope. Let's turn on the air blast and see how it goes. Cycle start. Oh, let's turn on the feed rate a bit, and then we'll turn it up again if everything's okay. Okay, it went well. First operation is finished. Now let's change to a 1/8 inch single flute end mill and rough out the text. Okay, so let's do rough out. Work coordinates are zeroed. Stock is set up. Let's turn on here. Put on the glasses. Oh, I know. Just okay. Should be set. Let's go. So it went rather well. It looks good. Let's continue with the 2mm end mill and do some more details. So the small 2mm tool is set up. The Z height is hopefully set up, and we can continue. final operation. Add some tiny little chamfers on the edges, and it should be done. So let's raise the spindle a bit. Everything zeroed, and yeah, we can start. And it's done. Looks okay. We didn't do any finishing tool parts, as it's probably not important. Just need top sides to burn in the graphics into wood or leather or whatever you're using. So, went quite well. Some places to improve in the tool paths, but generally not bad. Alright, thanks for watching and happy milling, everyone.